Polyglot persistence. Why should I care? How does this affect big data analytics? Hello, this project will introduce the subject of polyglot persistence. I will define the term and explain its place in big data and analytic applications. My name is Rjutkiewicz, an MLIS candidate, preparing this presentation for Dr. Singh's data analytics class. Merriam and Webster define a polyglot as knowing or using several languages. To apply this to polyglot persistence, Michael Assay has defined it where any decent-sized enterprise will have a variety of different data storage applications for different kinds of data. As an example, I will compare a standard old-school relational database considered by many to be a traditional stalwart utilized in many if not most of the traditional data storage technologies. The problem today is this limits what the user can do, as well as places a severe limitation in the speed at which queries are run on. Today's new school analytic requirements often see a number of different languages and databases used for today's real-time web applications. The mechanism for storage and retrieval of data is configured in many ways other than the tabular relations used in regional database applications. While there are many different categories and subcategories of not SQL databases, this slide provides an overview of the different types and categories. As an example, I will utilize the graph database Neo4j and demonstrate the use of this database and why the not SQL makes sense with today's big data analytics. This slide presents a more detailed classification presented by Stephen Yen. Still not sure about polyglot persistence? Let me summarize by offering that a single persistence type of architecture is ineffective at supporting typical business use cases that require the convergence of multiple data formats. Thus, today's CIOs and IM leaders need to assess the value of polyglot persistence. I'll try to demonstrate in the coming slides. In the world of big data, a relational database may tell you the average age of adults in the room. By contrast, a graph database, such as Neo4j, may be able to tell you who is most likely to buy a beer. How helpful would this be to marketers? This slide illustrates a typical property graph. It shows the nodes, relationships, properties, and indices for easy lookups. This table demonstrates that a social graph with 1,000 persons who average 50 friends per person and the speed at which Neo4j performs versus a traditional relational database, which takes 2,000 milliseconds versus 2 milliseconds with Neo4j. By the way, Neo4j can also perform about 1 million queries in roughly the same 2 millisecond time. This is why companies such as Walmart, Cisco, and eBay are utilizing Neo4j. The differences in the speed with which this application can perform queries is exceptional. In conclusion, instead of choosing between relational database management systems, Hadoop or not SQL and other data stores, why not choose all the data stores that are necessary to support one's business optimally? Polyglot persistence can provide the flexibility to do this by using multiple data stores for optimized performance. It provides the opportunity to use different cost structures among the persistence types when striving to optimize costs. Thank you. Here are the references for this presentation. Once again, thank you for your time.